So, today we're doing percent proportions. What do we remember from yesterday's traditional proportion problem? If we recall, we had examples such as the car one, right? You guys like the car example, right? The one where we had two cars. One was a miniature scale model of the real car. If the length of the car is 5 inches and the height is 2 inches, and the length of the real car is 8 feet, it's kind of big. What is the height of the actual car? The hardest part is to set it up in proportion format. Proportion format being like that. Do you remember why? Because this top row is representing inches and this bottom row is representing sorry, not inches, sorry. I shouldn't have said that. The top row is representing your height and the bottom row is representing your length, right? So that's why the X was there, because what we're trying to look for is the height of the real car. Now when you set it up like that, how do you find the missing piece? Easily. You just multiply 2 times 8. You pretty much find your cross numbers, right? The numbers that have something across from each other. You multiply that. 2 times 8 is what? You then divide it by always by the third number, which is 5. And then you ask yourself, how many times does 5 go into 16? And this is where you do 5 goes into 1 0 times, 5 goes into 16 3 times, creating 15. With the remainder 2, create the decimal. How many times does 5 go into 20? 1. Zero. So it's 3.2, right? But like I said yesterday, you guys could use your calculator to speed up the process for little stuff like this, because I care more about your proportion formats, how you're writing it, right? Today, though, we're getting into percents now. And percents are fun because we use that more in daily life, right? Proportions in general is actually used a lot. It's like one of those lessons in which you could actually bring in real-world problem into this. And percents is a big one. So in percent world, you're still going to use proportions. But there is 3 terms that you must know. Something called the part, the base, rates over 100, right? So part base equals rate over 100. That's going to be key. So if we noticed, going back to our traditional proportion problem, if you guys really wanted to, you could write the 8 over 2 as long as the, oopsies, you could write the 5 over 2 as long as the 8 goes up top and the x goes below, right? It's literally the same thing. So it doesn't matter how you rearrange it as long as your rows were all matching. In percent proportions, you are going to be following this formula right here. Part base equals rate over 100. It's important that you pinpoint exactly what everything is. So this is what I mean. This is what I mean right here. First, you must know what each of these means. So the rate is going to be the easiest one. When given a word problem, the rate will always be the percent in that word problem. All right? So rate is always your percent. The base is going to be the total, your total of whatever it is the scenario is, right? The total amount of your bill, the total amount of the shirt, how much it cost, right? It's always going to be your total. And the part is going to be exactly what it is. The part of that specific word problem. You guys want to see an example, I assume? Let me show you an example of a percent proportion word problem. There you go. Look how nice that is. I didn't want to write all of that down. So excuse the little 5-minute delay. So this is one of those questions where you're not going to find the missing piece. You're just going to identify the base, part, and rate in this situation. So if you read the question in the end, identify the base, part, and rate in the situation. So let's read it. At a restaurant, Janice's bill is $20. She gives the waiter a tip of $3, which is 15% of her bill. Well, tell me, what's the easiest one to always find? What's the rate? Yeah, it's always going to be your percent, right? And guess what? Percents are always going to be over 100. So now, what's my base? 20, right? Remember, the base is technically your total. Whatever it is the given situation is, it's always going to be the total of whatever it is, right? And the part is always going to be that little piece in the word problem that they ask for or that's taken out or whatever, right? In this case, what's the part? The 3, right? So this, we're doing exactly what we did yesterday, proportion still, right? But you must identify and you must place the appropriate numbers in its appropriate spot. In this case, your part, your base, and your rate. And the easy one, 100, will always be underneath your rate, right? It's always there, it's 100. And I think in the practice sheets that I'm handing out today, the first part that's always asking for is identify the base, part, and rate. That's all you're doing, which means you're going to actually write it out like that. Right? But obviously, that's not the fun part. The fun part is when they give you a word problem and they don't give you one of those numbers. So, here's another word problem. At a plant, come on in, at a plant that manufactures lighting fixtures, it is expected that about 2% of the fixtures assembled each day will have some type of defect. If 900 fixtures are completed in one day, how many are expected to be defective? Well, take it step by step. How about we set up our proportion problem? Let's set it up the same way we did it yesterday, right? What should go where? Tell me, you guys guide me, what should go to where? That's always going to be the easy one, finding your rate. And guess what? If you're given a word problem and they ask for what is the percent or whatever, right? If they ask for what is the percent, if you're not given the percent, guess what? That's the number you're looking for, which means it's going to technically be X or question mark or whatever you want to call it, right? That's going to be the number that you're trying to identify. But in this case, I have my percent right there. So guess what? That's my rate. 2 over 100 so far, right? What about my base and my part? One of them I know is going to be the missing number. Which one is it? Again, this is literally the hard part with percent proportions. Is setting it up appropriately so that we could cross multiply, then divide. So what should go where? In the bottom, right? It's your base. Let's read the word problem. If 900 fixtures are completed in one day, how many of those 900, so they're looking for the part, are going to be defective? So we're looking for the defective amount from 900 fixtures. You guys see that? You guys see how simple it is? So let's do our thing. We look for the numbers that have something across from each other, and we end up getting 900 times 2. What is that? Divide that by 100. X equals 18. So 8 out of 900 fixtures assembled, 18 will be defective, right? And this is the beauty of percent proportions is, sorry, did I jump the gun? A little. We cross multiplied, so you're always looking for the numbers that have something across from each other. In this case, 900 times 2, which comes out to be 1800, 1800. Whatever that total is, you divide by wherever the third number is. In this case, the 100, right? So we divide 1800 by 100, creating 18. So always cross multiply, then divide. But if you notice, the hardest part is that, given word problems, trying to find what are they looking for, this and that. But the beauty is, you could take this into real life, right? At last quarter, somebody used the example. They're like, all right, let me give you a question. If you go to a restaurant and the bill is, something dollars, and you leave a certain amount of tip, how much percent was that tip from the bill? And then we had an argument about how waiters should be tipped more and this and that. And then we went off and so off to a tangent, but whatever. You could take percent proportions into real life. Those shirts that are on sale, how much is it on sale by? 20% off, right? You find the amount that's taken off, and then you deduct it from the original price, this and that, this and that. You could take percent proportions into real life. You just need to know the percent. Or if not the percent, you just need to know the base and part. It's a little fun concept. Yeah? Okay, it's fine. Any questions on percent proportions? Huh? Nothing? Are we ready to put this to the test? Well, let's do this.